everybody, just coming on with a new video here, Automators Anonymous. Josh is my name. This video is going to actually talk about loop indexes, when to use the two different styles, why to use them, how they work, stuff like that. So we'll go into kind of a deep dive just on one actual specific project. A relatively simple project, nothing too big. This is actually from my friend Les Henderson in the Discord group. I was kind of helping him out with that, as he's one of my good friends. So he had this site right here, and he just needed to scrape this information here. So you can see that it's a list here, and the list actually goes this way: Alcona, Alger, Allegan, in order, alphabetical order. So what we see here is that there are rows. There's a table data, or there's actually a table body or table. You can go down further to a table row, to a table data, and then they have these A's in them, or they have the actual other information in here, the phone number. So the problem with this one, normally you would just go to this TR and then do a TD loop index 1, nth-child loop index 1 for these TDs. The problem with that is you cannot do that. Here's the real problem. Okay, so we have the T body. That gets us that far. Then we have a T body TR. What that gets us is the first row, second row, third row, all the way down. So we have 28 of those rows. So what we really needed right here is, because we have those rows, if you see down here, we need this row to go row 1, data 1, data 2, data 3, row 2, data 1, row 2, data 1, data 2, data 3. Well, that would require a loop index 1 here and a loop index 1 here. Within ZeroWork, you cannot have two loop indexes. So the way to fix that is, I don't know if I had it saved, is to actually, and it doesn't work within the in here, the browser, because it is a specific ZeroWork thing. So instead of having nth-child, we would do equals, that equals nth, no, I messed up again. That nth equals loop underscore index 0. Normally in this case, you would, or in the nth child, you would have a loop index 1. The reason for that is, in that case, that starts 1 is your first one. When you use this nth equals, for some reason the 0 is the first one. That's just probably a 0-1 thing, how they programmed it. So in this case, it's going to look for every the one T body, which is this. It's going to look for a table row, this row, and then a table data. This one, this one, this one. So it's going to look for all of them and go this way instead of that. So I'll show you what originally Les had, and it makes sense, and I understand why he did it, but it does not work. So first, what we have, you can see we go into here. The one problem at the beginning is he did a standard loop of 28. That's how many rows there are. So not that huge of a deal, though you could auto-detect it. What he did here is, because he didn't realize on there that there's this nth equals, or when to use it at least, he went and did that, and you could probably take off, you probably don't even have to have that much, but we'll just show it with that. That's a fine selector, not bad. He did, okay, the first one here, so it's going to go the first row and the first child of the data. So it is going to go Alcona, then Alger, then Allegan. Seems like what we want, right? So he does that in the first one, puts it in the branch name, goes to the second row, same thing except for it's a 2, puts it in branch name. 3, puts it into branch name. The reason this does not work is because of this single start repeat. And there's better ways to do this anyway. But so the better way, like we said, would be that nth equals that. So if we look at our start repeat, basically how this works is if you're inside the same start repeat and you want to put information in here, it's going to go row 1, all of these. So all you're doing here is it's inputting the first branch name, overriding it with the second branch name, overriding it with a third branch name. So what you're going to see here, we'll run it real quick. He also did have some 1-second waits on it. I did kick them down. I just put them to 0. A couple reasons to make this faster. As you can see, it was super, or actually is it this one? Okay, so there's a couple things here. There was an error. First reason there's an error, you can easily see it. We'll just go to the end. It's at the end. This one right here, 28th and the third one, does not have that A, so it errors out. Does not have anything in there. It's looking for inside this box an A for it. Doesn't have it, so it errors out. With that being said, doesn't really matter because it still works-ish. Part of it works. If we look at it, what we get is Allegan, Aranac, Bay, Branch. If we look at this, what we have is Allegan, Aranac, Bay, Branch. Like I said, it's going to put Alcona in. We can actually see that in our log here. So let's go to the first one. It puts in Alcona. Then it overwrites it with Alger, then overwrites it with Allegan. And so what you'll see is that is just that. It goes down and has Washington last. Yeah. Oh, it decided to somehow get Wexford. Very interesting. Oh, because it did not overwrite here. So it actually got that one first, then this one, and it tried to overwrite, but there was nothing to overwrite it with. So that makes sense why you would get the Wexford also. So there's a couple problems there. Obviously it errored out. We could have something like a check web element between these, and then it wouldn't have errored out. We would have just not done anything. But one of the main issues, I guess, is that it's overwriting. Okay. So the problem is when we're within a start repeat, it's just going to go, and when we're in the same item of it, when we're in the first loop of it, it's going to do it in this one. So if there was branch name 1, branch name 2, branch name 3, and he had put it that way, you would see the first one, and then you would see Alcona, Alger, Allegan. But when you do it that way, you just override branch name. So there's an understanding of that and why that didn't work. So let's go to, if you did want to do it this way, still not the best way, but it'll work. It's just a lot of things to do. On a site like this, Les had put 1 second. I know he likes to put waits and stuff. On a site like this, the reason I do waits on sites mainly is either to wait for something to come in. If like it's a scroll where it's waiting for more to come in, they might take a while. Or if it's a social media or some other platform that might ban you or something for doing automation. A site like County Road Association Michigan is not going to have anything like that. I build websites on WordPress all the time. I've never done anything for this kind of automation to stop it. There might be a time that they could, and there might even be some WordPress plugins maybe to stop automation. I don't know. There could be in some cases like Cloudflare that might be stopping it or something. But in this case, you're just pulling some data. It's probably not going to be a big deal. There's probably nothing they have from a site like that. So going next to alternate. Wow, you see it's kind of the same, but it has increased drastically to work correctly. Okay, so what we did here is we still go to the same thing. We start repeat. I did a 500. Again, you could auto detect it if you wanted to, probably, but I did a 500. And what happens is I decided to check the web element. So we're doing it the same way, essentially, as he had done it, Les had done it. I'm gonna see if we have information here. Yep. Delete all data. Okay, so we check the web element. If it's there, it's gonna be the first row, the first item. If it's there, it puts in that information, and I have 0-second waits here. It goes and gets basically the same exact thing from here to here. Okay, so if there's not, when it gets to 29, I would guess it is, because there's 28 rows, it will break repeat and we'll go to the next one. All this one does is another 500. Doesn't matter, it's going to break the repeat when there's not one. Goes to the second one, and then all the way up here to the third one. So this will work, but it's just a lot more work than you need to do. And each of the times it's checking web element, it's going to wait after the first column, so it's going to wait a second and a half, it's going to wait a second and a half, second and a half. So it just takes longer, and there's no real need for it. It just takes you a longer time to build it. If that was the only way you knew how to build it, fine, it would work. You'll see it'll work here. I don't have any waits, so see, it went to the 29th, and then it's looking for another one. Okay, it's not there, so it'll break the repeat and go to the next repeat. Okay, does 29. Okay, goes to the next one. Whenever it says okay, this one should be 28. Okay, because there's not that information down here. And then you'll see it trying to figure out if there's one or not. So it takes a little bit longer. And then it's done. No errors, no issues. Here's the problem with how it is. If you want that in order, alphabetical order, Alcona, Alger, Alagon, that won't work. It will put it Alcona, Alpina, blah, 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 down to Wayne, and then come back to Alger. And go all the way down to Wexford, Alagon, all the way down to Washington. So, in that case, it works. You might have to have a way to, if you want it in order, to actually reorder it or something like that, or in a Google Sheet, something like that. It may work for what you want to do, maybe just fine. It takes longer. It's more things on there. So, if we look at it, like I said, it'll go to Alcona, Alpina, Baraga, all the way down to Wayne, and then Alger, all the way down to Wexford. Okay, Alagon, all the way down to Washington. It works. I mean, it works. It took a long time. So, there you go. Here is the way I would do it. I can technically cut it down to 3. It would probably be better with the check web element. And here's, I'll show it the first way I did it. If this will bring in my check web element. There it goes. Taking a bit of time. Okay, so I'm gonna check this, and what you'll see in there, instead of like this, we have all the way down to loop index 1 here, and then a nth-child 1, and an nth-child 2. What this is going to do, we'll pop that there. If it's found, it does that. I am actually going to show kind of another thing here. But let's just say I can do this. I can put it at 500. I know there's not 500. Easy way to do it if you want. And then break a repeat here. So what's going to happen at this point? I always like to do this. Most don't, but boom. I like it how it looks. Start repeat. I started 500 times. Check my web element. And in this case, you can see I was doing that. So basically what this is doing is it's putting a, on the TR, it's putting a nth-child of 1 and a 1 here. Nth-child 1, 2 here. Nth-child 1, 3 here. 2, 1, 2, 2, 2, 3. Kind of like that, I guess I would say. That's kind of what it does. So it probably does it different in the actual background. It's just looking for anyone that's a T-body, TR, TDA. So in that case, what we can see, I have no weights. I'll go ahead and maybe this will come up. There we go. So we'll have that. What we'll see here is this is still working. And it's actually on this one. Boom, went there. Doing all of them. Okay. Did 82. So it technically did 83 of these because nth equals loop index 0. So 0 will be the first one. If we take a look at this, we should see. Let me pull a lot of these out of here. And what we will see, I got a bunch going on. What we will see now is this. So our first one started nth 0. So you can see that's actually our first one because that's Alcona. Goes down through and it just keeps going. And it works. Alcona, Alger, Algon, blah, 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 blah. At the very end, though, what we saw was it took a long time to check and see if there's one. Technically, there's a couple things we could do here. We have this, and I did it the wrong way first, so I just want to kind of show it to you. I'm like, okay, we just need to know how many TDs there are. If we do an auto detect here and do that, it should pull all the TDs. You'll see the problem here in just a minute, though, when I did it this way. Instead of running 500, okay, whoop, did I do the wrong one? There we go. Instead of running 500, now it runs the exact amount of those. I'll show you the problem, though, that I had. And then we're going to, at this point, it's always good to have a check web element, but technically I could, or I would have thought I could have done that right there. And then it's 3 blocks. It starts repeat, checking for how many of that there are, and then getting that. The issue here will be shown very quickly. It works. Going down to it, and then it stops at 82, which is 83. And then what does it do at the 84th one? Here's what happens. You'll see it'll error out. And I'll tell you exactly why it errored out. And I messed it up the first time when I was doing this. So it errored out because nth equals 83 would actually be the 84th one. Well, we only have, if we go all the way down, there's actually only 83. Dang it. Have to go, it'll be 166. Wexford. So there's only 83 in there, but it tried to go 84. Why was that? Because when I did the start repeat here, I did the TD, which if you see, this blank one is actually in that TD. So, in the table data. So the problem here is it's trying to pull something out of there, but there is no data. So all I needed to do to fix that was I should have just done it as an A. And then we should see it work. It is, like I said, always good to do check web element, but boom, this one technically can be done without, and it works. I just know it from how it is. And then watch. And then it's done, like fast, right on. So then if we look at it, what we actually see is it found only 83 of those items because there's actually that A within there. But when we did it this way, what we found is it tried to find 84 of the items because there technically is this area right here that is a TD, but it does not have an A. All the rest have an A. So hopefully that's helpful. Hopefully that gives you a better understanding of when to use loop indexes, what type of loop indexes there are, and what they do exactly. Also, hopefully it helps with understanding how the loop works. When you're in one loop, it's going to put it on the same row. Hopefully it also helps with understanding how this start repeat works, whether you're using a limit or an amount, or using the auto detect, that it's going to auto detect the exact amount on that page. So there's definitely good reasons to use all these things. A lot of times there might be lists that have an auto scroll or something, the weird scroll, and those may not work as well like with this. So I just put them to like a 500 because I know there's not that many, let's say, items, and then I just break repeat. So in that case, it'll keep checking, keep going down and down and down the list. When it's done this way, it's checking right at the beginning how many are there, even if it is unlimited scroll. Because if it's unlimited scroll, it's going to say, okay, there's 25 of them, I'm going to do 25. If there's unlimited scroll and you have 500 in this number, then what will happen is it'll go down to 25, and then it'll keep trying to scroll down and down, and then you can still actually get more than that. So that's another reason why you might use the number sometimes, and then just do it like I had done it before, where you do a break repeat after it's done finding any more of them. So yeah, that's all I had for today. Definitely hope that was helpful, and definitely would love to see you back on some other videos and watching some of the videos. If you have more ideas of what I should make videos about, definitely let me know. I'm more skilled with XPath and CSS is kind of my big thing. Not as much as APIs and stuff, though I'm getting into understanding those a little bit more as well. So until the next video, we'll talk to you then.